K-12s. What I figured I would do so we don't miss out on another class is I'm going to teach you about two new groups, the carboxylic acids and the esters. So you should have this in front of you now, this handout that I provided the teachers covering you. Okay, so what I'm going to do is I'm going to go through it. If you want to take notes as I'm going along, you can. If I'm going too fast, you can always ask to see the video again. All right, carboxylic acids are quite similar actually to the aldehydes in terms of how you name them and where they're located. So here's an example of the carboxylic acid. This is the functional group that you will see. And this is only found at the end of a chain. So that's how it's similar to the aldehyde. Notice the carboxyl, the carbon double bond to the oxygen, but instead of with aldehydes being an H, it's an OH. Now, the reason that they actually call them carboxylic acids is because when they're in an aqueous solution, they tend to lose their hydrogen ions very well. And so when the hydrogen ions end up in the solution, they actually make it more acidic. All right, now, these, like I said, only are found at the end of a chain. And the other thing you should know is that when you're doing the ending, when you're naming the molecule, it's going to be an oic acid ending to the name. So oic, two words, oic and then acid. Okay, so what are some uses for carboxylic acids? There's a number of different things. You can find them in preserving foods. They're actually in Europe. They're in painkillers. They're found in paint. They're found in adhesives. And another kind of fun fact is they're found in sweat. Now, when dogs, for example, are used for like sniffing out things, like for example, if someone has gone missing or they have been killed and they're somewhere in the woods and they bring out the dogs to try to find the unfortunately dead person, what they actually can smell is the carboxylic acids in the sweat. So I thought that was kind of interesting, a little depressing, but still interesting. So that is another kind of use for carboxylic acids, sort of indirectly. Okay, naming them. Like I said before, they're very similar in terms of naming them as we did the aldehydes. So this would be the simplest one. Okay, so this is called methanoic acid. And interestingly enough, this is what's found in ant bites, this particular chemical. Similarly, another one that's pretty simple would be this one. Okay, so this one would be considered ethanoic acid. And notice, and this is something again that I mentioned to you guys with the aldehydes, the carbon that is double bonded to the O, and then the O, and then single bond to the OH, that's actually a part of the parent chain. So this would be ethanoic because there's two of them. You can have them where they have a branch. And I know I keep drawing this in the same way, but you can actually draw them where the OH and that is on the opposite side. So this would be an example if you had a branch. Okay, so again, what do you think should be given priority in this scenario? Always a functional group. So if we count this, it's going to be 4. It's coming off the third, the branch, so it would be 3-methyl, and it would be butanoic acid. And again, with these ones, you don't actually need to say where it is because you're again assuming that it's at the end of the chain. You could have a scenario where you have a double or triple bond in the molecule. All right, so again, same idea is you want to give priority to the functional group. So in this case here, the triple bond is coming off of the third carbon, so it would be 3. We have 1, 2, 3, 4, 5, 6. So 3 hexanoic acid. Okay, would be this one. Okay, so again, very similar to naming the aldehydes, except that it's a different functional group, so it's going to be a different end. Okay, this one's a little weird, but I really like this group actually. These are called the esters, and we will be doing a lab next week on these. Now, let me kind of explain this one because it is, like I say, a little bit different. So this is your functional group. Notice again the carboxyl, the C double bond to the oxygen. Now, coming off of the carbon that's bonded to the double O, this is going to be your parent chain. And then anything coming off of the single oxygens there, see the single bond, that is always going to be a branch. So what's great about that is you don't have to put any numbers for the branches because you can assume that that's where the branch is coming from. Now, the ending that you're going to use for these when you're naming them is going to be an O8 ending. Now, these ones typically don't create any cyclical molecules, so you won't really see that. And they have to, I guess, I mean, they can be at the end, but generally, you know, you'll see, these are better examples of them here. So for example, if we look here, this would be your parent chain, and this would be your branch. And then down here, same idea. This would be the parent, and then this would be the branch. And again, please be careful because I have seen this mistake before. This carbon does count as a part of the parent chain. Okay, so don't forget to include it when you're trying to name it. All right, one of the cool things about esters is they smell really nice. So oftentimes you see them in soaps and powder and detergents, perfumes. They also are used as food flavorings and in medicine. So they have been used to treat diseases such as leprosy, which you don't see very often anymore, and asthma, which is pretty common. Okay, when you're naming these ones, okay, again, it's going to be the O8 ending. So let's do this one here. And again, you can draw the oxygen on the other side if you want. I'm just drawing it this way. All right, so here is a typical one. So over here, remember, this is going to be your parent and this is going to be your branch. So since it's just one carbon, it would be methyl. And then we have 3 carbons here, so it would be methyl propanoate. Here, another one we could do. And this is actually a very common one, the next one I'm going to draw. Okay, so this one, this time we have an ethyl group as the branch, so it would be ethyl, and then we have 2 ethanoate. Now, ethyl ethanoate is actually a pretty popular chemical in terms of the esters. It is used in industry, so it has been around actually quite a while as well. So another name that they use for this molecule is actually ethyl acetate. So I don't know if you guys remember last year in your chemistry, and even on the back of the periodic table I gave you guys, there is an acetate ion. Okay, so that's part of where the name comes from. But ethyl ethanoate and ethyl acetate are actually considered the same thing. Okay. Last slide is the reactions. So the lab we're going to be doing next week is going to be fun because it's going to be, you guys are going to be adding chemicals together and watching and predicting different types of chemical reactions, and it's going to be involving esters. So I'm just going to show you some of the different types of reactions that could apply to the lab. So the first type of reaction that you see with esters, okay, is called esterification. That should sound familiar because this was something you did in grade 11 biology, so that would have been like the grade 10 biology course. When you joined glycerol with a fatty acid, it was an esterification reaction. All right, this one is also classified as a dehydration synthesis. And again, we talked about this quite a bit last year. Removal of water when you're joining molecules together. So in this first reaction, you're actually creating an ester. And I want you to look and tell me which molecules do I need to make an ester? Okay, so take a moment just to draw this down. Okay, so notice this molecule here, the first one, is a carboxylic acid called ethanoic acid. The second one is an alcohol, and this is ethanol. Now, it doesn't actually have to be eth and eth, that just was random, okay? But you do, in order to make an ester, it's going to be a reaction between a carboxylic acid and an alcohol. Now, I want you to look at this, and I want you to predict how it's going to bond. Remember that a dehydration synthesis is going to be the removal of a water. So, can you see where you would remove the water? Right here. Okay, and then these are going to join. So what you're going to end up with is this molecule. Plus water, and this molecule would be called ethyl ethanoate or ethyl acetate, as we saw before. Now, this reaction is reversible. So you can add water to an ester and create both of those byproducts as well. All right, now another type of reaction that you potentially could see would be a hydrolysis reaction. Now, I know in the past, when we talked about hydrolysis, we've talked about it adding water, but hydrolysis here is actually not just adding water. It can also be adding water or a base. And I don't mean at the same time, I mean like at different times. And in this, you need the presence of an acid as a catalyst. So if you recall, when we talked about a catalyst enzymes last year, they help for the reaction to take place. So I want you to take a look at this first reaction that I'm going to show you. Okay, and you can see what happens. So we are going to take, I guess we'll do a different one this time. This time we're actually going to start with the ester. And you can see this one would actually be called methyl propanoate. Okay, because of the methyl group, and then we have the 3 carbons, right? And we're going to react it with sodium hydroxide. All right, so what I'm going to do is I'm going to show you the reaction, and then I'm going to want you guys to try on your own reacting the same molecule with water and seeing if you can figure out what would happen. Okay? All right, so I'm going to draw out what the new molecule is, and I want you to tell me, all right, well, we'll discuss it, kind of, what happened. Okay? So sodium, oxygen, and hydrogen, the sodium and the OH bond is going to break. So where do you think the sodium is going to go? The sodium is actually going to replace the methyl group. So the sodium is going to attach, okay, to that single O and basically replaces the methyl group and becomes the new part of the new molecule. Okay, so I will draw that here. All right, now this would actually be called sodium ethanoate. If you're putting on a metal, you just literally are going to name the metal, and then you're going to name, sorry, that should be propanoate, my apologies. Okay, propanoate. Now, what do you think you're going to get now? So this methyl group is all by itself. What do you think it's going to bond to? The OH. So now you've just produced an alcohol, and this would be methanol. Okay, so in this reaction here, when you have a base, you are going to produce an ester. It's actually called an ester salt in this case, and you're going to produce as well an alcohol. All right, I want you to try this on your own. And what I would like you to do is now see if you could react it with water and try to predict what would happen. All right, so that is your lesson about carboxylic acids and esters. So what I'm going to do is I'm going to get the teacher who's covering you right now to give out the practice problems for you to try. And then next week we will take them up. All right, guys, have a great weekend. Hope this helped. Bye.